Okay, so I'm just going to kind of walk through another one. It's another diprotic acid. You'll see on a practice coming up triprotic, so it'll give you a chance to work through that. All right, so here we have carbonic acid. That's a diprotic acid. Again, you're given the two Kas, and it wants us to find the equilibrium values of the various molecules and ions, and then also the pH. So this is going to look pretty similar. I'm going to kind of move through it a little bit quicker, so feel free to pause it and just try this out on your own and then check your work after. So we're going to undergo the first ionization of the carbonic acid. So I'm going to write out my reaction with water. It's going to produce our hydronium ion, and then the remaining anion that's then going to undergo a second ionization shortly. Set up my ice table. Right, we were given the initial concentration as 0.075. Again, we're going to start off with 0 for our initial concentration of hydronium and 0 for the concentration of the anion. And then keeping in mind it's going to proceed to the right, and using our balance equation, I can include my various x's in their correct place and then summarize it in our final equilibrium step. All right, and then going from there again, it's going to be similar to what we just walked through. So we have our Ka1 is equal to our products over our reactant, original weak acid. So Ka here is 4.5 times 10 to the negative 7, which is going to be equal to x squared over 0.075 minus x. Again, we're going to make that simplifying assumption in order to just simplify our work, and that's going to end up being less than 5% of our original amount, which means x, which is our concentration of hydronium, which is also equal to the concentration of HCO3, is equal to 1.8 times 10 to the negative 4th. Okay, so that's some of the information we were looking for there. And again, I always go back, if I remember, and just fill in those values. If you actually do plug it in this case, you end up with the same amount, which I think was one of the values they were actually looking for up above. Just to quickly take care of our simplification here, you end up getting, if you plug this in, 0.24%, which we know is less than 5%, so that checks off. All right, again, you should at least be able to plug that part into your calculator and avoid writing that whole piece out. Now remember, this concentration of hydronium is then going to allow us to figure out the pH. So we can take the negative log of that value, which gives us, rounding to 2 sig figs, 3.74, which was another piece. And again, like we just talked about in the previous example, yes, there's going to be additional hydronium from the second ionization, but it's going to be an insignificant amount to affect that pH. All right, then we can move on and undergo the second ionization. Okay, that is going to react with our water and then leave us with the carbonate ion and hydronium. Okay, remember this is the part where we don't need to actually write out an ice table. We're going to use the values from our previous first ionization. So for here we have our Ka2, which again is going to be equal to our products over our reactant. Okay, our Ka2 that was given to us was 4.7 times 10 to the negative 11, which makes sense. It's smaller than our Ka1, which is what we would expect. We can fill in the concentration of the carbonate, or sorry, the hydronium. So actually I want to fill in here X. Okay, and that X is our concentration of CO3. And then our hydronium we're going to use from our first ionization. And then we're going to use that same concentration also as the HCO3 anions concentration, so 1.8. Okay, that then allows us to know that X, which is that concentration of the carbonate ion ends up equaling the Ka2, which is 4.7 times 10 to the negative 11. Okay, so we can put a little X around that. And again, the biggest piece with that is that carbonate ion, the CO3 with the -2 charge, that is the anion that's left over after the last ionization step. So that's going to have the smallest concentration of all the ions in solution. Okay, thanks for hanging in there with me for this long. Hopefully seeing the second one kind of summarizes it a little bit better for you, and you'll see some in the practice later on.